Okay, in this video, I'm going to look at a problem where we have got a fourth degree polynomial equation with two undetermined coefficients a and b. We're told that a and b are real numbers, and then we're given only one root. We're told that z equals 1 plus 2i is a root. So the first thing I wanted to do is to find the values of a and b. Got two unknowns, only one condition given. Then after that, we're going to show how to find the other roots. Okay, so the first thing that you might be wondering about here is that, we have got two unknowns, so we need two equations, but we're only given one condition. However, since this root is complex, then it's going to actually from one equation give us two equations, as we'll see. So let's just work through it and you'll see how this works out. So what we're going to do is simply take this thing and plug it in here. So z we already know, so we need to work out z squared, z cubed, and z to the power 4. So z squared is going to be 1 plus 2i all squared. So it's going to be 1 squared plus 2 times 2i, and then plus 2i squared. So this is going to be 1 plus 4i plus 4i squared. Well, I squared is negative 1. So this is 1 plus 4i minus 4. So this is 4i minus 3. So that's going to be z squared. Then z cubed is the same as z times z squared. So z is 1 plus 2i. Z squared is 4i minus 3. So if we just remove brackets here, then we're going to be good. 1 times these is going to give us the same thing. Then 2i times 4i going to be 8i squared, and then 2i times negative 3 is going to be minus 6i. 8i squared is the same as negative 8, because I is negative 1. So what's going to happen here is this thing is going to give us the real part is going to be negative 11. The imaginary part is going to be 4 minus 6. So it's going to be minus 2i. And then finally, z to the power 4 is going to be equal to, so we can write this as z times z cubed. So z is 1 plus 2i. Z cubed, if we factor out the negative, it's 11 plus 2i. So, and then we're going to multiply out here. So if we, so I'm just going to put the negative outside. Again, if we multiply 1 into this, which is going to have 11 plus 2i. Then 2i times 11 is going to be 22i. And 2i times 2i, it's going to be 4i squared. It's going to be negative 4. So this is going to be the negative of 11 minus 4 is 7, and that is going to be 24i. So this thing is minus 7 minus 25. So that's z to the power of 4. And then, so what we're going to do is we're going to take each of these and plug them into this equation here, z to the power 4 there, z cubed there, z squared there, and z there. And then this thing, of course, must be equal to 0, since 1 plus 2i is a root. So if we do that, this is what we're going to get. So z to the power 4 is negative 7 minus 24i, then plus a times z cubed. Z cubed is minus 11 minus 2i, then plus b times z squared. Z squared is 4i minus 3, then minus 2z. Z is 1 plus 2i, and then plus 5, and this is equal to 0. So what we're going to do now is we're just going to remove brackets and simplify. So when we do that, so we've got that minus 7 minus 24i, that's going to be minus 11a minus 2ia plus 4ib minus 3b, and then from here minus 2 minus 4i, and then plus 5 equal to 0. Then at this point, this is where we end up with two equations. We're going to bring together the real terms, and the imaginary terms will be on their own as well. So if I just look at the real terms, this is what we're going to have. So I got minus 7 minus 11a. So it's just the terms that do not involve I. And so looking at these, so just look at the numbers. We've got minus 7, minus 2, which is minus 9, and then that's going to be plus 5. So that's going to give us negative 4. And then we've got minus 11a, which is this one. And then we have got minus 3b. So that's all the terms that do not involve the number I. And then for the terms that involve the number I, the ones that do not involve the unknowns, we've got minus 24 minus 4. So that's going to give us minus 28i. And then we have got minus 2ia minus 4ib. And this is equal to 0. Just going to tidy this up a bit. So we can write this as a negative 4 plus 11a plus 3b. Let's say minus I into 28 plus 2a plus 4b is equal to 0 on the right hand side. We're going to write this as 0 plus I times 0. Then what we're going to do is we are going to, what this is implying is that the real numbers on the left hand side must balance out the real numbers on the right hand side. So that means this term here must be equal to 0. So if we equate that term to 0, so we're going to get 11a plus 3b is equal to negative 4, because this must match with that. So let's call this equation 1. Then we do the same thing with the imaginary terms. So in that case, we are going to get 2a plus for B, looks like we made a slight error here. Let me just check my working. So with these ones, yeah, the sign of the 4IB there is positive, so that should be positive, and so it means here that is going to be negative. So here we're going to have negative 2A plus 4B is equal to 28. So that's going to be our equation number 2. So then now it's two linear equations, 2 unknowns. We solve this as usual. What we're going to do is we're going to multiply 1 by 4 and multiply 2 by 3. So 1 times 4 is going to give us 44A plus 12B is equal to minus 16. Multiply equation 2 by 3. So the idea is that the B terms are going to match up. So this is going to give us minus 6A plus 12B, and then 3 times 28. So let's work out 3 times 28. 3 times 28 is 3 times 28 is actually 84. Then if we subtract here, if we subtract the second one from the first one, this is going to give us 50A. The B's are going to cancel out. Then 16 and 84 going to give us negative 100. So this is telling us that A is going to be negative 2. And then if A is negative 2, then we can plug into one of these other equations. We are going to actually find that B is equal to 6. So what this thing is telling us is that the equation we have is z to the power 4 minus 2z cubed plus 6z squared minus 2z plus 5 equal to 0. Now when it comes to the part B, finding the other roots, we're actually going to recall that since all the coefficients are real numbers, if 1 plus 2i is a root, then the conjugate of it is also going to be a root. So that means from that we can have 2 factors, and the 2 factors are going to be z minus 1 minus 2i. From z equals to 1 plus 2i is a root. The other one is going to be z minus 1 plus 2i, and this product is going to be a root as well. So we're going to multiply that out. So if we do, z times z is z squared, z times negative 1 is negative z, z times 2i is going to be plus 2i z. Then now we multiply through by negative 1. Negative 1 times z is negative z. Just going to align the like terms. Negative 1 times negative 1 is plus 1, so I'm going to write that there. Then negative 1 plus 2i is going to be minus 2i. Then the last term to go is negative 2i times z is negative minus 2i z. We write that there is a like term with this one. negative 2i times 1 is, sorry, negative 2i times negative 1 is plus 2i. We'll write that one there. The negative 2i times 2i is going to be minus 4i squared. And then we simply add up the like terms. So this is going to be z squared minus 2z. These cancel out, these cancel out. So this is going to be plus 1. This is going to be plus 4. So this is giving us z squared minus 2z plus 5. So this must be a root. Sorry, a factor as well. So that means if we divide this by z squared minus 2z, we should get a remainder of 0. So indeed, let's work through that and see how it goes. So z to the power 4 minus 2z cubed plus 6z squared minus 2z plus 5. So first, z squared goes into z to the power 4, z squared times, then z squared into this, going to be z to the power 4 minus 2z cubed plus 5z squared. If we subtract here, this is just going to give us z squared. Bring down minus 2z plus 5. So then z squared goes into z squared once, so plus 1 here, and then multiply 1 into the divisor. It's going to be z squared minus 2z plus 5. Subtract. So what this thing is telling us is that our equation we can write as z squared minus 2z plus 5 into z squared plus 1 equals to 0. The roots from this factor are 1 plus or minus 2i. The roots from this one are going to be plus or minus I. And so we have got all 4 roots. Okay, so at this point, we're going to give you an opportunity to work through the second example. So in this example, we're told that minus 1 plus I is a root of this polynomial equation. A and B are real unknowns. So you're going to want to find the values of A and B and then find the other roots as in the previous example. So I think you just want to pause the video, work through this, and then we continue the video. You can compare with our solution. All right, we're now going to scroll down to our solution for the problem in number 2. We would like to thank you for visiting our channel and watching this video. We hope that the material is useful. We do implore you not to forget, please don't forget to subscribe to our channel and like the video and share accordingly. If you have got any questions, we would like to hear them. Just post them in the comment section. If the video is helpful as well, we would like to hear that type of feedback. All right, so for number 2, this is our polynomial. A and B are real. We're given that minus 1 plus I is a root. So if we work out z squared, it works out to negative 2i. Z cubed works out to 2 plus 2i. Z to the power 4 works out to minus 4. So if you plug into the equation, this is what we get. Remove brackets and then collect terms. Real terms work out to 4 plus 2a. Imaginary terms work to 2 into 1 plus 8 minus b. So 4 plus 2a is equal to 0. This tells us that a is going to be equal to negative 2. Then if a is negative 2, from the second equation, that tells us that b is going to be equal to negative 1. If we plug in negative 2 here, so b is going to be equal to negative 1. So our equation then is going to look like this. Then from the root negative 1 plus I, this is the factor we have. Since all the factors are real, it means the conjugate is a root as well, and the associated factor is this one. Multiplying these two gives us this quadratic here, z squared plus 2z plus 2. Then dividing the polynomial gives us this as the other quotient or factor. So that means the equation, we can write it like this. From this one equal to 0, we've got these two, and then the other one gives us 2 plus or minus I. All right, thank you.